Peace be upon you all around the world, and welcome to another tutorial in C language. In this video, I'm going to do my best to explain to you the binary search, how it works. Before that, we're going to get into definitions, and then we're going to see how it works. Then we're going to apply it in the C language. And if you could apply it in the C language, I'm sure that you could apply it in any other language that exists out there, such as Python, JavaScript, or any language you prefer to work with. So, we're going to see the algorithm and apply it step by step in C language. First of all, this is the definition. Binary search is a fast search algorithm with a runtime complexity of O log n. This search algorithm works on the principle of divide and conquer. For this algorithm to work properly, the data collection should be in the sorted form. As you see here, we're going to sort an array, then we're going to apply the rest of the algorithm. Binary search looks for a particular item by comparing the middlemost item of the collection. If a match occurs, then the index of item is returned. If the middle item is greater than the item, then the item is searched in the subarray to the left to the middle item. Otherwise, the item is searched for in the subarray to the right of the middle item. The process continues on the subarray as well until the size of the subarray reduces to 0. And we're going to see this in detail in how binary search works. Here we're going to see how it works and how all of the definition that we read here we're going to see. For a binary search to work, it is mandatory for the target array to be sorted. So first step, we have to sort our array. We shall learn the process of binary search with a pictorial example. The following is our sorted array, and let us assume that we need to search the location of value 31 using binary search. So we're going to look out for the index of this value here, 31. If the user, for instance, entered a list, a number of a length of the array, for instance, equal to 9, then entered values, and then we're going to say, for instance, where you want to say the index of the number 31. So first, we shall determine half of the array by using this formula. Mid equal, this is the middle, equal the lowest number, and it represents 0, plus the highest number represents 9. Then we're going to subtract the lowest number, it is 0 again, then divided by 2. That's it. So 0, as you see here, 0 plus 9 and minus 2 is equal, divided into equal 4, and it's basically equal to 4.5. But as soon as we're working with integers, we're going to just get the 4 number, and 4.5, it is a floating number or a double number. So no need to that, we need just an integer number, and it is 4. So after that, see here that the half of the array, or the number 4, it is the half of the array. And 4, it is here, and next to it, right away, we're going to find the index number 5. So, now we compare the value sorted at location 4 with the value being searched, 31. So we're going to compare 31 with the value of 27. We find that the value at location 4, this value is 27, which is not much. That means if the user entered 31, actually it's not equal to the middle of the array. So what we're going to do, we're going to jump to this, and it is greater than 27, greater than the middle of the array. We're going to jump to this part, or this portion of the array, and make all of the rest numbers to default, like not exist. And So we also know that the target value must be in the upper portion of the array, as they said here. So as I said already, all the previous numbers, we make them like not exist anymore and just work on the half or the other half of the array and apply to it the same thing. So as soon as here 31 is greater than the middle of the array, we're going to start our subarray with the middle plus 1, because the middle is not equal. So we're going to start it from the middle plus 1, and it is 31, value 31 at index 5. So up to the last index. The same thing we're going to retype. Low is going to be middle plus 1, and the middle is going to be updated to the lower value, and it is 5. Then the highest is 9, minus the lowest, it is 5, then divided by 2. So it's going to give us 7. You could calculate it easily. So lowest number, it is 5. So here 9 minus 5, it is 4. 4 plus 5, you could just calculate it easily. You're going to find 9. 9 divided in 2, or this portion here, you're going to find number 7 in the middle, as I said here. And then the process is going to be continuously working like that. And as I said, the 7 is the half of this array. Then we're going to apply the same thing. 7, this is the half of it, and we're going to find that the number that entered by the user, or the value that we're looking of its index, it's smaller than this half of the array. So we're going to make the rest on the right like of numbers, including the middle number, it's like not exist. So all we get here 31 and 33, and then as soon as it's not matches the 33 number, it's basically matches the 31. So the 31 is going to gives us back the index of 5, and that's it. How we reach to the or how it's the binary search works. So now we're going to ignore all of this, or not ignore this, but we're going just to apply everything that we saw in the C language. As you see here on the screen, I have just a binary search.c file, has just a basic template here, or structure, includes stereo, input and output .h, an integer of the main function. Then we're going to apply our stuff. First of all, we need to get length of an array and the array from the user. So let's say count, that going to represent the length of the array. After that, we need to define an array. I'll go with an integer array. Then we're going to get the elements. Up to now we're good. We get how many number we want in this array, and we set or getting the elements inside of the array. We could print easily here a message just to make sure that the user entered the values in the right position. After that, we need to sort this array. I'm going first of all to find this function at the top. And before I'm going to write anything inside this function, I'd rather to complete the code inside the main function. So after sorting, just assume with me we sort the array. We're going to jump to that in a second. Now, after sorting an array, what we need to do is getting the number that we want to search on it. So let's say, for instance, x. We're going to search on x, or search on the index of x. Position better. Then we need to create our function, or before that we're going to print a message to enter the x value and then enter it to the machine. After that, we need to create our result function. And here we're going to use the recursion. So we need a binary function, binary search. And we're going to pass in it the first index 0, then the count -1, and that reaches the final number in the list. Then we need the array, and after that we need the x element that we're going to search on it. That's it. We could easily now print the result out. And this result is going to be an integer. That's it. Now what we need to do is complete these two functions. First of all, we're going to define this function up there, here, just like this. And the first one, I'll leave it to void function. And here, I'll leave it to integer as soon as it's returned as an integer. So here, the lowest number, I'll say low. And this is the length of the array, I'll say integer of highest. And here and here, they are all integers. And also, these an array. That's it. I'm going to copy these two functions and I'll pass them here. We're going to sort. First of all, if you don't know how to sort an array, we're going now to use one of the 3 method or the 4 method in sorting an array. So I'm going now with insertion sort, and you could go with bubble or any method that you're familiar with to sort your array. So now I'll go with insertion sort. That's it. So we're going to print the sorted array. Now everything with the sort function is working perfectly. What we need to do is just jump to the function, the binary search, and apply what we saw in this page to it. So first of all, we're going to need an integer, or to compare to see if the highest number is greater or equal to the low number. If so, what we're going to do, we're going to apply our rules by first of all define the middle of the array and calculate it, applying this equation here. Here it is, the same equation. I just copy it and pass it inside of here. Let me remove this. Here we are. Let's do this. And then we're going to say if the array at position mid is smaller than the x, the number that we're looking for, that basically mean as soon as is greater than x is greater than the middle, that seems like we're going to work with the middle plus 1 or the subarray on the right. So we're going to return our function, the binary function here, the same function, but let me first remove these things, and the lowest number is going to be the middle plus 1 up to the highest number, and we need to define this array. That's it. Otherwise, if it's greater than the x, that means we're going to start from the lower number up to the mid minus 1. Exactly like this. And there's another condition. If it's equal exactly to the x, what we need to do is just to return the mid. Exactly like this. So if the user not entered one of the numbers that exist already in the array, we're going to return minus 1, for instance. Exactly like this. So I think no need for this bracket because the code is clear. And so let's give it a shot. I'll run it and see what's going to happen. So the length of the array, I'm going to say 5 numbers. Enter elements, I'm going to say 61, 50, and 12, 10 for instance, and 1. So enter element, the sort of array that gives me this is 1, 10. It's not quite as I expected to be the structure. So let me jump to the void here. So the length of the array is going to be, for instance, 5, 60, 30, like this, and 1. So the sorted array and sorted, so x, let's say 2 is present at index minus 1. Why? Because the 2 is not in the list. So let me edit this first, and then we're going to complete the things out. Here we are, and let this in a loop. So while 1, we're going to do this. You could import the boolean by doing here include stdi bool.h and use while true, but I'm using while 1, and basically it means the same while true. So let's run it again. So the length of array is 5, As you see here that I entered values not in sorted array or not in sorted order, and I hit enter the sorted array. It is 5, 10, 12, 35, 45. Now it gives me in sorted array. Like enter for instance the last number. So if I enter here 45, I'm going to expect to give me the index number 4. So digit 45 present at index 4. So let me do something. I'll jump to here to print a null line behind index 4 to have that cool structure. I'm sorry. So let me jump here and do a new line. And here, lengthen of array, I'm going to print a line here. And here also I'm going to print another line. Okay. Delete it, I'll run it again. Here we go. So length of an array, I'll say 5. I'm going to enter the same numbers that I already entered. And I'll say, as you see here, the sorted array is now the other one sorted array. I'm going to enter 45. So digit 45 present at index 4 as I expected. If I enter 10, it's basically has to give me indexed 1. So 10. So digit 10 present at 1, 5 should be 0, 0, and 12 should be 3 or 2, and 35 should be 3. So they are working perfectly. And if I enter the number not in this array, for instance 2, not in the array, so it's going to return -1. We could print a message like this number is not in the array, but we just returned -1. It's kind of not in this one because our array is just start counting from 0 up to the infinity, and -1 is out of the range. So also if I enter this number, is going to be like this. So I hope you get some information and you benefit yourself. Don't forget to support me, and thanks for watching, and stay tuned and peace out for another tutorials.